Okay, here we are on part 2. And before we do the last example, I do want to mention angle of elevation again. It kind of surprised me in the middle of the problem, which I hadn't taught it yet. Let me zoom in. It's having trouble focusing, isn't it? Alright, see if that helps. I don't think when it doesn't have enough light, it does that. But anyhow, the angle of elevation is always established from a horizontal line. It's often the ground, but it wouldn't have to be. And from it, the rotation creating the angle is upward. It's elevated, like an elevator. And it creates an angle with that horizontal. So this is an example of angle of elevation. It could also come from the other side. What I mean, here's the horizontal, and it might rotate this way. Both of those are angles of elevation. When we have a horizontal, when we have a horizontal that is high and we're coming down off of it, like say that's the flight of an airplane. When we have a straight line that is above and we rotate downward from it, we create an angle as well, and that's called the angle of depression. But no one's sad. It's just the title they gave it. And that can go the other way as well. You could have it coming off of this side and you could come down this way and create an angle. Oops, bent that the wrong way. The angle is going to come this way. And that is also an angle of depression. So both of those. So angle of depression, the horizontal is above and the angle is below it. Angle of elevation, the straight horizontal is below and the angles are above it. So here, this is the one we used. The angle of elevation, angle of depression. All right. That'll show up sometimes. It's just a term and it'll help you find what angle they're talking about. All right, this time I won't give you the triangle first. I'll just give you the scenario. Say there is a lighthouse, and the lighthouse is 200 yards from a path. Let's say a walking path. So here's the 200 yards, and here's the walking path. The walking path is along the water. All right, and the walking path has a connection with another path, and that path is a biking path. So we have a walking path connecting to a biking path, and this forms a right triangle where at this point, so we're going to be able to use our trig functions. So I happen to know that this biking path is twice as long as the distance from the lighthouse to the walking path at the water's edge, so that makes this 400 yards. So what I want to find is the angle. Were you wondering the angle there between the walking path and the biking path? Admit it. So I'm going to use one of the trig functions. The trig functions are sine, cosine, and tangent. So which one will use this angle and this known side and this known side? So we want to know this, so we need to include that in our problem. And this opposite and this hypotenuse. So hearing the words opposite and hypotenuse tells us to use the sine function. So I'm going to write sine of some unknown, theta, equals the opposite, 200, over hypotenuse, 400. I'm going to simplify that. If I put it in the calculator, it'll be 1.5. If I reduce it, it'll be 1/2. So this says I need to know this angle, and the clue I have is the sine of that angle is 1/2. Well, we've seen that angle pop up in our unit circle, so we can look there. But what if it's not on the unit circle? What if this is sine of theta is 1/3? Then the unit circle can't help us. So I'll show you how to tease it out of your calculator. You're going to hit sine inverse, so that the calculator will be able to tell you the angle that has this, as its sine. So that's sine inverse. It is second function. It's above the sine button. It looks like sine to the -1. It's read sine inverse. And second function, sine to the -1. That sine to the -1 is not cosecant. So just be aware that that sine to the -1 there is not the inverse reciprocal function of sine. It is inverse sine. So it's when you're looking for an angle and you're given the number. So I'm going to put sine inverse 0.5. Enter. When I did that, I got 30, and it's in degrees. So 30 degrees is the correct answer for that problem. All right, so when you hit sine, let me write that down, what you put in there. Sine inverse of 1/2. And that will give you, that was unclear, so I'm erasing it. Sine inverse of 1/2 gives you 30 degrees, and that is the angle between the walking path and the biking path. All right, now that all of our questions and curiosities are satisfied, we will end this time together. Sad but true. See you in the morning. Goodbye.